In this video, we're going to continue on with solving some special types of first-order differential equations. And in this, to start here, we want to talk about a function f of t comma x is said to be a homogeneous function of degree n if every term of f is a monomial of t and x of a total degree n. For a quick clarification on what all of that means here, let's look at this example. Determine whether the following functions are homogeneous or not. So here we have a monomial t cubed x, which has total degree of 4. Right? We just add the sum of our degrees there. This monomial is also 4, and this monomial is also 4. So since all of those monomials have the same total degree there, this is a homogeneous function. Let's look at the second one. Well, this one has degree 4, degree 4, degree 3. Okay, so this is not a homogeneous function. All right. This is 1/2 times something of degree 1. So it's 1/2 plus 1 is the total degree. So it's 3/2. And that is the same here. So it's 3/2. So this is a homogeneous equation, or function, excuse me, homogeneous function. And then sine of t is a no. That would not be a homogeneous function. Okay, quick side note. We will be talking about homogeneous differential equations later in the semester. That is defined differently than this homogeneous function. So those two things are different. So I'm going to point out later that you will have, again, a definition of a homogeneous differential equation, which is different than what we are talking about here. But let's move on to a different definition. And that is that a first-order differential equation of the form dx dt equal to m of t comma x divided by n of t comma x is said to be star homogeneous if both functions m and n are homogeneous functions of the same degree. Okay. Well, if we look at this first one here, we get a t minus x, so that is degree 1 in the numerator and degree 1 in the denominator, and both are homogeneous functions. So this is star homogeneous. All right, so look at the second one. We get degree 2 here, degree 2, and then degree 1. So that is not a homogeneous function in the numerator. So this is not a star homogeneous function. All right. In this one, if we rewrite it as dx times t squared minus tx, move all of that to one side, and this is equal to t negative of t squared plus x squared. dt. And then we can take this dt, divide that on both sides, so we get dx dt, and divide the t squared minus tx through on both sides, so we get negative t squared plus x squared all over t squared minus tx. Well, in the numerator, we get a homogeneous function of degree 2. In the denominator, we get a homogeneous function of degree 2. So this is a star homogeneous differential equation. All right. If we look at this fourth one, we can move the 4t squared plus x squared over to the right side. So we get tx x prime is equal to negative 4t squared minus x squared. Oh, sorry, plus x squared. Then we can divide by tx. So we get x prime is equal to negative 4t squared plus x squared all over tx. Again, the numerator has degree 2, is a homogeneous function of degree 2. The denominator is a homogeneous function of degree 2. So this is a star homogeneous differential equation. All right. And in this final one, we get degree 2, degree 2, degree 0. So this is not a star homogeneous function. All right. Now, once we know how to recognize these, we want to make a substitution u equal to x over t. If we make that substitution, we will then turn the problem into a separable equation that we can solve. So here's how we do that. If u is equal to x over t, then this implies that tu is equal to x. Well, then what is dx dt? Dx dt is equal to the derivative with respect to t of u times t. This is a product rule. The derivative of u times t plus the derivative of t, which is 1, times u. All right. So what all of that means is that the dx dt, this right here, is going to turn into du dt times t plus u is equal to, and then m of t comma x, n of t comma x. And here, what do we want to happen? Well, here we are going to replace x with u times t everywhere. Everywhere we see an x, we replace that with u times t on the right-hand side. And that will be our solution. This is what you want to remember or circle, because we're going to use this every single time for these problems. So once you have that written down, we'll move on to the next one. And now let's go ahead and take a look at this first example. We got 3 examples to run through here. All right. We need to rewrite this into that form that we just wrote down. So that is du dt times t plus u is equal to t. Now we replace x with ut. So this is t minus ut all over t plus ut. And now this is the equation that we want to work with. This is our separable equation. Notice that on the right-hand side, we could factor out a t everywhere. So this becomes negative of u minus 1 all over u plus 1. All right. So this whole thing becomes du dt times t is equal to negative u plus 1 all over u plus 1 minus u, right? I just subtracted this part over to the right-hand side. And then we want to combine like terms. We want to combine our fractions here. So how do we do that? Well, we multiply this u times, multiply that by u plus 1 over u plus 1. And this becomes negative u plus 1 minus u squared minus u all over u plus 1. which is equal to 1 minus 2u minus u squared all over u plus 1. Okay. So now we need to separate our variables. Well, to do that, we multiply by u plus 1 on both sides. We divide by 1 minus 2u minus u squared. We still have a du over on the left. And then we divide by t, and we multiply by the dt. So this is dt over t. And this is now we have now separated our variables. All right. Real quick change here. I prefer to have a positive u squared on this term so we can factor out a negative out of that denominator. And this will actually become negative of u plus 1 all over u squared plus 2u minus 1. Again, I just factored out a negative out of that denominator. And of course, this is equal to dt over t. All right. Now that we have that, if you recall our method for solving these separable differential equations, we need to integrate both sides. And I left off a du there. Sorry, this is times du. So now we need to integrate both sides. We integrate the left with respect to u, and we integrate the right with respect to t. Okay, so go ahead and do that. This is a u substitution problem. Here, I'm going to call it a y sub because we have already used u as a variable. So do a y substitution with y equal to u squared plus 2u minus 1. So review that and do that substitution. And once you do that, you should get 1 over 2 integral of dy over y is equal to, and multiply the negative on both sides to move that over to the right. So this is negative the integral of dt over t. All right, we integrate those. This is 1/2 ln of absolute value of y is equal to negative ln of t plus c. All right, so we want to go back and replace what y is. Y was u squared plus 2u minus 1. So this, in fact, becomes 1/2 ln of u squared plus 2u minus 1 is equal to negative ln of t plus c. But u was x over t. And so we rewrite this then as 1/2 ln of x squared over t squared plus 2x over t minus 1 is equal to negative ln of t plus c. And this is our solution. All right. We got 2 more to go through. For this next one, if we rewrite everything and put it into dx over dt is equal to some function m of tx over n of tx, we get to this. Dx dt is equal to negative of t squared plus x squared all over t squared minus tx. If you recall, we actually did that at the beginning of this video. So this is our equation. This becomes du dt times t plus u is equal to, and now we write out the right-hand side, but x is going to be replaced with u times t everywhere. So this is negative of t squared plus t squared u squared, all divided by t squared minus t squared u. So again, I just replaced x with t times u everywhere, which we can factor out that t squared on the right-hand side, and we get du dt times t plus u is equal to negative of 1 plus u squared all over 1 minus u. Then we subtract u on both sides, and we combine our fractions over on the right-hand side. And after several steps, we're going to get du dt times t is equal to negative of 1 plus u all over 1 minus u. Now we need to separate our variables, and we end up with u minus 1. I just factored out a negative 1 here, right? So this denominator is the same as negative times u minus 1. So then those negatives cancel. And now we u minus 1 over u plus 1. Times du is equal to dt over t. All right. And so this is the equation with our variables separated. Well, we need to reduce the left-hand side. We can reduce the left-hand side by dividing u minus 1 by u plus 1. And we get 1 times that is u plus 1, subtract. So this is negative 2. So this means that u minus 1 over u plus 1 can be rewritten as 1 minus 2 over u plus 1. All right, so that left-hand side actually becomes the integral of 1 minus 2 over u plus 1 du. So write all that out. This is, again, the integral of 1 minus 2 over u plus 1 du is equal to dt over t. All right. Now we take the integral of both of those, and we get the integral of 1 is, with respect to u, is u. The integral of 2 over u plus 1 is 2 times ln of u plus 1. And this is equal to ln of the absolute value of t plus c. Now we just need to replace u with x over t. So all of that becomes x over t minus 2 times ln of x over t plus 1 is equal to ln of t plus c. All right. We have one final example to do. We are done with this video. Again, earlier we rewrote this already as x prime is equal to negative of 4t squared plus x squared all over tx. And so this becomes du dt times t plus u is equal to negative 4t squared plus t squared u squared all over t squared u. Factor out a t squared everywhere. All of those should cancel. So this right-hand side is actually negative quantity 4 plus u squared all over u. Okay. Now, at that point, we want to subtract the u over and combine the fraction over on the right. When we do that, we end up with du dt times t is equal to negative 4 minus 2u squared over u. Or in other words, negative of 4 plus 2u squared all over u. All right, now we want to separate our variables. If we do that, we end up with negative u over 4 plus 2u squared du is equal to dt over t. All right, now we integrate both sides with respect, well, the left side with respect to u, the right side with respect to t, and we make a y substitution for the left side of y is equal to 4 plus 2u squared. If we do that, dy is equal to 4u du. So we divide by 4 on both sides. This tells us that dy over 4 is equal to u du. And that's the substitution we want to make. So this all becomes 1/4 the integral of dy over y is equal to, and then I went ahead and multiplied that negative that I had on the left earlier, move that over to the right, integral of dt over t. All right, we take the integral of both sides, the left with respect to y, the right with respect to t. We get 1/4 ln absolute value of y is equal to negative ln of t plus some constant c. We replace y with with 4 plus 2u squared, because that's the substitution we made. And we get that this is 1/4 ln of 4 plus 2u squared is equal to negative ln of t plus c. All right. And finally, this u squared becomes x squared over t squared because u is x over t, and we get to this final form down here. And that concludes this video.